Hello dear viewers, today we are doing Redoxgleichungen mit System, and this is likely for me only because I need to understand this, but if anyone else is watching, welcome, and if you're bilingual, even better, because I will be talking English mainly because I cringe listening to myself talk German. So, this will more be in Denglisch though, but yeah. I keep on forgetting what to do with Redoxgleichungen, especially when this is a system because it kind of gets tricky. So I'm making a video for this in a way that I will understand and hopefully you will too. So that in case I need it, I will remember it. And I'm writing schriftliches Abi, Grundkurs, Chemie, in exactly a week from today. So this is me studying and keeping this in mind, and next term, this term we're doing Elektrochemie, which apparently this year is useful for. I mean, it is useful. But this is also studying. So, over here we have a Permanganat, we have a Wasserstoffperoxid, H2O2, we have Mangan, and we have 2 Sauerstoffatomen. So, we'll start off with the first step, which is the Oxidationszahlen bestimmen. So, as a rule, Sauerstoff is always -2. Well, mainly. And H plus, so 1 Wasserstoffatom, is always 1 plus. And this here gets written in römische Zahlen. So we go here. The rest is all like relative. So we go here, we see there are 4 of these, so it's 2 times 4, which is 8. But the thing is, and the whole piece, this whole chunk here needs to Ausgleich, except for this here has a negative Ladung, which means it needs to Ausgleich to be negative. Well, this is -8, and this doesn't say -8, it says -1 for the whole thing. So this here needs to be +7. This here is a Sonderfall, because we have 2 O's, which comes to 4, -4, and 2 H's, which comes to +2. And then we don't have a negative Ladung here, it's equal. So this here is what we call a special Fall, in which case they both have 1. This here stays negative, by the way. This here has a gesamte Ladung of +2, so we do +2. And that's the whole thing. And this one, I remember we said -2, but like it's another one of these Sonderfallen. However, this here is now elementar because there is nothing else. Elementar is a begriff which here means ±0. We see in Baden-Württemberg you write ±0 according to my Chemie teacher. In other countries, other Bundesländer, I mean, it's probably a bit different, but here, I'm saying here like I'm in Baden-Württemberg, I'm in South Africa, which is why it's Denglisch. Because German is not my first Sprache. Over here, this is also important, by the way, we will get to that. Now, we actually start the Redoxgleichung. So, Red and Ox. Redox. So, we need to find out what the Redox is and what the Reduktion is and what the Oxidation is. So, over here we go to my little Merktabelle. I would suggest you schreibt that auf. And here, the +2's in the römische Zahlen is there to represent Oxidationszahlen. I just didn't want to write the whole word. So, Oxidationszahlen, if they go up, so we're looking from the Verhältnis from this side to this side, and we're taking these as a block. So we look at the MnO4 minus, we look for the other Mn, okay, these 2 blocks belong together, and these 2 blocks belong together. And we're not focusing on the O over here, because there isn't an O here. Same as we aren't focusing on the H over here, because there is no H, we're focusing only on this O. So, we look at these Oxidationszahlen, goes high to low, and if it goes the Oxidationszahlen go higher, it is an oxidation, so it goes at the bottom. well, not at the bottom, here at the bottom, I'm just writing Oxidation after Reduktion. Which means this here would do that, because -1 goes to 0, goes higher. And here, +7 goes to 2, which is lower. Reduktion, and you will soon find out the Produkt and Edukt thing I wrote there. So let's write that down. MnO4 minus reagiert zu Mn2 plus und hier Wasserstoffperoxid CO2. So now we've done the first step, which is saying what the Reduktion is and what the oxidation is. Perfect. Second piece. Now let's write that down. And we will just remember to leave a space here, because we will find out now. Reduktion is by the Edukte. So we're going to leave a little space by the Edukte. Let's first write MnO4 minus. Leave a space, weil Mn2 plus. And Oxidation. And well, there's a space here by the Produkte. Now, to find out what this is. So, we have 7 Elektronen by that Mn, by that Mangan, and we have 2 here. And now, 7 minus what gets us to 2? That's right, 7 minus 5. Amazing. So, we need like minus Elektronen, just think of it that way. Oh, this says E minus, Produkte E minus, Edukte E minus. Edukt E minus, yeah, egal. Because now we will plus those 5 E minuses. Because look here, we have like 7 positives. We need 5 negatives to get to 2 positives. Does the math make sense? Is it nothing? I hope so. Now we're going to do the same thing over here. In which case we will end up with 2e minus, because of this 2. So this is -1 times 2. So we have -2. And we have 0 here. We need to -2 over here. Because here Edukte, Produkte. Edukte by the Oxidation are here, Produkte are here. We need this here to come down. Make sense? I hope so. Just remember it like that. Remember this here and you'll be fine. Okay, now time for, as my math teacher says, Komma du was. So, we do those Striche. And now, at the end we don't want to have like long stuff with these E's. So, we're going to make sure that they're the same so that we can just stretch them out. So in order to do that, we have to times whatever we put here in brown at the top here, and whatever we put in brown at the top, we times at the bottom. So times 2 and times 5. Important to remember is that it's not just this here getting times, it's the whole everything. So let's just write that down. This is technically the 3rd step, but I'm just writing it ausführlich in the 3rd step. We'll see why. See, I already forgot. Okay. 2 MnO4 plus, now we have 10 here, remember? Because this here, 2 times 5, 10 E minus 2 Mn2 plus. Ox is 5 H2O2 reagiert zu 5O2 plus 10 E minus. Wow. And now you're gonna do the abstreiching, the kürzing. But we're gonna do that all together. So we write a redox because it's together like a nice sandwich. So we're gonna take this, the Edukte all together. So 2 MnO4 minus plus 10E minus plus 5 Wasserstoffperoxid. reagierst du 2mn2 plus 5o2 plus 10e minus. And now, my dear friends, we can stretch that. Lovely. And we can move on with our lives. And if you're asking why it is unfortunately just the way it is, just remember that's what you do because Chemie. There are a lot of stuff that are sometimes difficult to answer in math and Chemie, and to that I just say because math or because Chemie. It's easier to accept it. Unless it's like Grundniveau stuff, which this might be to some people. But they probably know the reason why as well. For me, this is 12th grade Chemie. So, yeah. Perfect. Now we have this written down nicely. And we get to the actual System, which will be the 5th step. Now, basically what a System is this here, I will add a definition somewhere here. And what I basically understand of it is, because I don't know the definition right now, is that we put, it's the Gleichung in a Lösung. You can have it in a saure Lösung, in which case we add H3O plus ion, which is what we are doing in this video. Or you add OH minus ion, which is basically exactly the same. And they generally tell you the Aufgabe. If not, then I guess you just write, it's probably an explanation then, and you just write H3O plus ion oder OH minus, kommt drauf an, in welcher Lösung es ist. And you add Wasser, that is the 6th step, which we will do later, not now. So, we are going to do this here. Now, I wrote this down for the System, but only for the stuff that's not Wasser, so the Lösung it's in allgemein. See, it's in a Lösung, so it also needs Wasser. Remember it like that. So big number and the top Ladung, but technically this is a mal, the top Ladung. The top number over here. So this is the big number I was talking about. These big ones in front, and if there isn't a big number in front, it's a 1. So over here we have 2, and we have a minus 1, because there's only one minus. So we do 2 times this gesamte Ladung. That leaves us with minus 2. 5, there's nothing here, so we assume it's a 1, to my knowledge. Ladung is 5. And just remember, this plus goes down. And then we will write the answer. Oh, my pen is running down. So minus 2 plus 5 leaves us with what? Yes, 3. And I'm just going to do 5 over here. And we have 2 times 2, positive 2, is 4. And that there is 5. So this leaves us with 9. Now we come to the point where we like 3 plus was ist gleich 9. And to that, okay, and it can also be the other way around. It can be like, if this here was 3 and this was 9, we still do this. And whichever side has the lower number, this is where we put our oxonium ion, I think it's called, H3O plus ion, minus 3. What is that you say? A 6. Perfect. So that is exactly what we are going to be adding in as I write it down in the next 6th step. That is how many H3O plus ion we need, and it will go on this side because it has the lower number. So, Redox. Now we schreibe all of this auf again. 2mn hoch 4 minus plus 5. Upsis, ich habe eine 0 da vergessen. H2O2 Now, where we add the 6 H3O plus Ionen. Yay! Because now it's like the same, you know? They're vibing the same, on the same level. And that goes to 2Mn, 2 plus 5O2. Now for the Wasser. The Wasser always goes on the opposite side of where the H3O plus or OH minuses are. For that, I'm going to be writing with this green highlighter because I do not have any more markers. They're dry, and it's like the end of the year. The end of the term. Do I really want to be getting more markers? Okay, this is for the Wasser. You know, it also kind of like matches because it kind of looks more blue. So, this part you are going to be counting the H-tone and the O-tone, but really only the O's are important, so technically you can just do that there. However, the H's are there to like überprüf. Whatever. So, I'm going to write H here. I'm going to do both, because it's good to have in your head. So, we're going to count. Are there any H's here? No. Are there any H's here? Yes, there are 2. However, we need to remember that there's a big number. So, we do 5 times 2, which is 10. There are 10 H's. Here, there are 3 H's, but it's 3 times 6, which is 18. Yay, perfect. Yeah. So we have 18 plus 10, which is 28 H's, and I'm just going to do the reagierst du, because now we're counting it on this side. Oh, would you look at that, there are 0 H's. Now for the O's. Here there are 4, but 2. So 8 O's. Here there are again 10 O's. And here there are 6 O's. Well, this is the last time where I miscalculated by like 1 and then I was losing my mind. So we are going to be using attachment. As I'm sure you noticed, the video is just being cut because I realized that I put in the wrong Werte. I even got a calculator, a whole calculator to berechnen that, but I still made a mistake. So I put in 3 here for some reason. I think I looked at this 3 and I was like, yeah. Anyways, this here, this 8 plus this 10 and this 6, it gets 24. So now we have that, and there are 10 on that side. Because 5 times 2, and there are no zeros here, or O's. Okay. And now we're going to be minusing this here. So 28 minus 0, the H's. Still 28. Now here's the point where you can divide this by 2 because it's H2O, in which case you will get 14. And here, 24 minus 10 is 14. Yay! And when these here are matching, that means great, you found out what the Wasser is. So it's 14 H2O. And that is how you berechne Redoxgleichungen im System. I actually hope you can see this because it's kind of like glaring a bit. It's fine, you were listening. That is how you berechne Redoxgleichungen im System. With this example that we did in class, thank you for watching. If you have any questions and you are not me, please let me know. I might be able to answer. Or else, go watch a video from Bizo, Mathe, Physik. He's a great teacher. Thank you for watching. Bye.